This is a Module 1 video on enthalpy and entropy. Enthalpy is measured by calorimetry, but in many validated cases also correlates to differences in the heats of formation for products versus the heats of formation of the reactants. From the 1957 paper cited earlier, the heats of formation were determined at 415 Kelvin, but I will share with you another source of this information, which are the standard thermodynamic properties of chemical substances at 298 Kelvin. The PDF is available on the Canvas site. The heat of formation is the change in enthalpy forming a substance from its elements, and not necessarily in the gas phase, but at a stated temperature and pressure. And for the standard thermodynamic properties table, that will be the elements at 298 Kelvin and 1 bar of pressure. For both reactants and the product, the heats of formation are negative. Therefore, each of these compounds is more stable than the elements. Hydrogen as a gas, carbon as a solid, or bromine, which at 415 Kelvin is a gas. We can then take the sum of the heats of formation of products subtracted by the sum of the heats of formation of reactants and determine a value that matches very closely to that measured by calorimetry. For the class meeting, please come prepared to discuss what this information tells us about this reaction. Turning to the last page of the worksheet, this describes entropy in terms of energy dispersal arising from changes in 3 degrees of freedom: translational freedom, rotational freedom, which is tumbling, and vibrational freedom, which includes bond rotations as well as bond stretches and bends. Entropy is not really disorder. That can be a macroscopic manifestation, but it is more accurately energy dispersal. The Gibbs free energy equation has both an enthalpy and an entropy term, but only the entropy term is affected by temperature. If we know the change in enthalpy measured by calorimetry at a known temperature T, and if we also know the equilibrium constant at that temperature, for which we can then calculate the change in free energy delta G, we can calculate delta S, change in entropy. For the reaction of isobutene plus hydrogen bromide to produce tert-butyl bromide at 415 Kelvin, the change in entropy is negative 158 joules per mole per Kelvin. In the class meeting, we'll discuss what this value of delta S tells us about the reaction. This concludes the video on enthalpy and entropy.